Hi, I'm Tom Biebighauser with Wetland Restoration and Training. Today is a special day. We get to build a wetland from start to finish. You're going to be attending a wetland restoration workshop at Ball State University, the Cooper Farm, and here we are near Muncie, Indiana, and I'm surrounded by cornfields and native prairie grasses. This is a great place to restore a wetland area because wetlands were drained here. I have found the best way to learn how to build a wetland is to actually build a wetland. I started teaching these hands-on wetland restoration workshops over 20 years ago, and we have taught thousands of people how they can build a wetland. They get involved in the design and the planning and the layout, supervising construction, planting native species, and then monitoring wetlands that we built in previous years. So I'm happy you're with us. Enjoy today and learn how to build a wetland. So Tim, I have some questions about the wetland that we're looking at building here.
Yeah.
And first of all, we know where we want to build it. It's a level area and it's been mowed. But I have a question is, how deep should we make the wetland?
Well, so we have worked together for a number of years now,
Yes.
and we've built a lot of wetlands together on this property in areas around here. And the thing that we found interesting is that the traditional depth of wetlands that works in other parts of the country or the regions doesn't seem to hold as much water or for as long as it does in our area or would in our area. So what we have done is with each successive wetland, we've made them deeper and deeper and deeper, and yet we're still seeing that some of them, well, all of them are drying out every year and are truly ephemeral.
Do you remember how deep the first wetlands were? Were they like less than a foot, or were they?
The first wetland, I think, had a maximum depth of, I want to say 15 to 18 inches. And that one,
it dries up.
It dries up even too early, right? And
Okay.
then we went to our next wetland, which we went for about an 18 to 24 inch depth, and it's a wider, bigger wetland. And that one does okay, but it still dries up.
When does it dry up? July, August, September?
Earlier, probably
Earlier,
late June,
okay.
late June to early July, which is getting on the borderline of too early.
Well, now last year, 2 years ago, we built something 3 foot deep.
Built
That has to be perennial.
Nope. And so
It's not.
even this last 2 years, our wetland that has 3 foot deep sections has dried out every year by mid-July.
Wow.
It has just got dry, cracked dirt in the bottom. So
That is amazing.
Yeah.
Because we understand the value of ephemeral wetlands is what we've been building, but we want them to hold water long enough for many of the species to develop.
Yes.
And these may be drying a little bit too short.
Yeah.
Now, we've been disabling the drainage features.
Absolutely.
We have high clay in
Yep.
this content in the soil. So I think this year we need to look at going deeper in the
yeah,
middle.
I'm excited.
All right, let's do it.
All right.
This looks like a great place to build a wetland. Look at how level it is. I see a lot of goldenrod. Let's take a look at the ground. Oh, look at this, right here. That is the chimney from a burrowing crayfish. And what they've done is that they've burrowed down into groundwater and they've covered the entrance of their hole with the soil that they removed from burrowing. And what that shows us is that we can build wetlands here because crayfish will burrow down until they hit groundwater, and they will be in that groundwater, all night long. Well, I should say all day long, and then they come to the surface and forage, and that shows us that we have a permeable layer down there, plus we have groundwater, and that means a lot when it comes to building this wetland. We have to make sure that we interrupt that permeable layer, otherwise this wetland won't hold much water at all. I want to show you how to build a wetland that looks and functions like a natural wetland at a low cost with a minimum of cost for engineering. Basically, you're going to do the engineering out here today, and this is going to bring the cost of the project way down. I have found that most wetland projects now, the cost of design and engineering exceeds the cost of construction. And we're going to show you how you can reduce those costs and be even more efficient. Anyone here an engineer? Wow. Do you think you have to be an engineer to build a wetland? No, you don't. I'm not an engineer. I teach engineers how to build wetlands, but I'm not an engineer. You know what, if I were to do it all over again, I would probably hire a tutor that would have helped me with calculus, then I could have become an engineer. But at 18 years old, the last thing I wanted to do was to go through calculus 1 through 4. Just other things on my mind.
I'm John Taylor. I'm Ball State's Field Station and Environmental Education Center land manager and restoration ecologist, and I've been working in this job for about 24 years. And we're at the Cooper Farm, one of the 5 or 6 field station properties, and this is a 100-acre farm, and we have prairie and woodland and now wetlands, thanks to you and your assistance with our workshops.
And thank you to you and Ball State University for hosting this Hands-on Wetland Restoration Workshop, a unique opportunity for people to come in here and learn how to build a wetland in one day. Pretty amazing. Now, behind us is where you're looking at building the wetland, and I'm wondering, why did you choose this place? Why do we want to build a wetland here?
Okay, so Cooper Farm is very flat, and we have clay soil, and there are some drainage tiles and some low areas in around it. The water naturally pools a little bit down here, but not a lot. So it's got some wetland plants, but it's not a wetland yet. It doesn't have standing water for more than a few days at a time in the year.
So in looking at the area, I see it's quite level. The contour map shows that it is level, and yet it's not a wetland area. And we know that the soil is quite high in clay. So why isn't it a wetland? If it's that high in clay and that level, how come we're not seeing it being a wetland? Do you have any idea?
Yeah, I think part of it is that it doesn't have a deep enough basin, so it just kind of runs off to the next lowest area.
Do you think a farmer may have shaped the land so that the water would run off? I
think that the farmer probably drained the areas that were holding water, and we do have drainage tiles around this, but this spot in particular, I'm not positive that they did much at all with it.
Every wetland we have built on this farm, we have found the buried drainage structures, some quite large diameter. And I was talking to Dr. Carter, and he thinks we'll find them here.
We may. They are around. I mean, they might be on either side of it.
It'll be a eureka moment if we do, won't it?
Yes, it will.
Okay, all right. Now is that we're going to mark where the perimeter of the wetland could be that we build and see what you think as far as size goes.
Sounds good.
Thank you.
All right, thanks.
All right, I'm happy everybody's here. We're going to build a wetland today. That's a good day. My name is Tom Biebighauser. I work as a wildlife biologist and a wetland ecologist. I started building wetlands in 1978. I would say that's probably before a lot of you were born. I really like to dig holes in the ground to help fish and wildlife, and that's what we're going to do out here today. Then we're going to start with Clint Skirvin, most important person here today. He's the one who's going to be running the excavator. And Clint started helping us build these wetlands when we had our first workshop, maybe, I don't know, 6, 7 years ago, maybe longer. And he's a very busy individual, but he makes a special point to be out here on this weekend to help us with the wetland, and he builds really nice wetlands. You'll be seeing them either later today or tomorrow. We're going to take a tour of all the wetlands we built over the years, which will be really good. So Clint, I really appreciate your help. Then we have Larry Dixon. Larry, okay. Larry is our professional photographer, videographer. Last year, Larry and I started producing videos on how to build a wetland. We have 10 that are on my website and YouTube channel. And this year we hope to produce 15 more videos. But this will be an interesting one about workshops. Well, we're going to start in right away with the wetland work. First of all, we're going to talk about safety. I want you all to be able to go home tonight and be healthy without any injuries. The number one concern is keeping away from Clint on the excavator. I'm amazed that he's willing to do this with a group this size. This is a huge group, and normally on job sites you only have, I don't know, half a dozen people to watch out for. So what that means is that we should stay together as a group and stay in front of that machine. If you're behind the machine, he can't see you. And by all means, do not go to the side of the machine. Look at the right side of the excavator. There's no visibility. If he swings and hits you, that's the end of it, right there. And I have been on jobs. I was on one job where we were building a wetland and we were placing large woody debris, and the excavator operator grabbed this big pine tree and he started to swing it in position. and he knocked one of the observers to the ground. He thought he killed her. Fortunately, she wasn't hurt, but it was really embarrassing. And it happens. These are big machines, so keep your distance. If you need to go to use one of the bathrooms, go way around the machine. Don't take a shortcut. We're going to start out by taking some elevations. We're going to find out how much slope there is to this field. And then we're going to mark a wetland to build. And then I'm going to ask Clint to dig a test hole. And Jesse is going to help guide us through analyzing the results of the test hole. And then we'll start construction. So, sounds like a plan, huh?
With me is Amanda. And where are you from, Amanda?
I live in Indianapolis.
Indianapolis. Mm-hmm. And what brought you to this training session?
I work with the Alliance of Indiana Rural Water, and my position with the Alliance is focused on source water protection. So any kind of projects or initiatives that are happening statewide to protect the quality of water. So I was interested, wetlands are a big issue here in Indiana, especially recently. And they have great potential for environmental and public health benefits and managing stormwater. So just seeing how easy they can be installed and what uses they can have and what benefits they can provide the communities.
Well, Tom has talked at length about drainage versus wetlands versus swamps and so forth. So what do you see as the benefit of a wetland?
I think it has a lot of environmental benefits for plant and animal species, but they also offer a lot of water quality benefits. So especially if they're used in conjunction or near built areas, so they could be, stormwater could be directed that way to support the wetland and support the environmental function, but also offer social benefits like improving air quality and supporting trees. And I think the benefits can just be stacked.
So at this point, which we're in today too, has there been a major takeaway that you're going to leave with?
I think that it's maybe not as, constructing a wetland is not as out of reach or complicated as maybe people make it out to be, or it can kind of seem. So their implementation with the right thinking ahead of time, with the right design and key considerations. Once you address some of those key considerations, you can implement something relatively easily with some big equipment, and especially if you have the right people kind of helping you out in the planning process, and just kind of let nature do its thing, kind of let it fill, watch how it does, and go from there.
Good. Anything you want to add?
No, just that I appreciate the opportunity to be here. I feel like I've really learned a lot, and I feel like the application can be really widespread and have a good and wide impact.
Well, thank you.
Thank you.
All right, so we're going to start in by taking some elevations. We have found a level area here, and also we have done what's called a utility check. So we've checked for buried utilities, and we're in the clear on that. And maybe when you parked your vehicles and you see where the outhouses are, you can look on the ground and you see some paint, white paint, and that shows that we had the utility check. When they came out here, they marked it that we're in the clear, which is good. This technology has been around from the 1970s. They've used it a lot to drain wetlands, and I've picked a higher ground on the edge of the project. Hopefully we can leave it set up here, and it is what they call self-leveling. So now I push the green button, and if you're close, you can hear it starting to level. When it levels, it'll start rotating. Don't stare at the beam, okay? That's one of the warnings. They're afraid people are going to stare at the beam. And it hasn't started turning yet. Okay, now it's turning. And here is the rod. I just turned on the receiver, and this is just going to spin all day. Just spin, spin, spin. And what we're going to do is we're going to walk around with this rod, and when it intercepts the beam, you hear the solid tone, the flat line. Now it's intercepting the beam, and then I can read the back of the rod, and I'm reading a 5.4. So if I go to higher ground, I'm going to have to shorten the rod, and I'll read a lower number. If I go to lower ground, I'm going to read a higher number because I have to extend the rod. So we're going to be taking some readings here. And this is probably the most important tool that you're going to use outside of an excavator when building a wetland is to get your own laser. Let's walk. There's another pink flag on the ground. We'll take a reading there. 6.0. If you would, turn that so people can see it. Okay, so this was a 6.0. That was a 6.2. If we go to higher ground, we have to shorten the rod. We're on higher ground, 2/10 higher, about 2.4 inches higher here. So now I'd like you to take some of these wire flags from Tim and go ahead and mark the edge. And you can put these in maybe every 8 feet apart. Try 8 to 10 feet apart. We've now marked the perimeter of the wetland we want to build using these wire flags. Clint, who is the excavator operator, is digging a deep test hole in the center of the wetland that we would like to build. We are going to determine soil texture by layer, and these results will help us decide how to build the wetland.
My name is Dr. Jessica Haft. I'm an associate professor of soil science at Ball State University, and I really love soil. I'm just gonna get it cleaned up and ready for you to look at, and then I'll start telling you what we're looking for and pointing out some things to you, but it's a little easier to see some of those features if I just kind of pick it out a little bit, because the backhoe smooths out the surface and can hide some of those features. Notice as I'm picking through here, you'll see where it takes more effort. As the soil gets more dense, the deeper we go. We're going to talk about some of the soil formation processes here that have developed the perfect scenario for wetlands across most of Indiana. How many of you heard about the glaciers and the glaciations that happened across this region and north of us? Right? So there's definitely been some giant ice cubes, if you will, that were very heavy, that came through multiple times. There was multiple events. And so a lot of the soils across this region, it gets sandier down here, that's not good. Got the life squished out of them, if you will. And so they get really dense in the lower portions. Typically across Indiana, we tend to see a silt loam or a clay loam or sometimes a silty clay loam surface. It's lighter and easier to work through. And then with depth, we increase in clay content. So another thing that you want to look for when you're looking at these soils is color. When we see redoxomorphic features, that indicates that there's either a seasonal water table or there's water that doesn't move very well through the soil. It either fluctuates throughout the soil profile or it sits there for a reason. Maybe it's sitting on top of the glacial till, or maybe there's a seasonal water table. So what we're looking for in terms of color is grays and then orange or reddish streaks or blotches.
The excavator operator is now removing the few trees and shrubs that are in the work area and setting them to the side. We're going to later place them in the finished wetland to provide good habitat for invertebrates and a variety of wildlife species. The excavator has dug a core trench around the lower 2/3 perimeter of the wetland that we're building, and now the operator is placing soil that's high in clay in this trench and compacting it in layers, and this will help keep water in the wetland. We call this process the building of a groundwater dam. I would like to show you a tool called a penetrometer. P-E-N, penetrometer. It's for measuring compaction in the soil. Now there's two types of compaction. There's good compaction and there's bad compaction. When you're building a forested wetland, you don't want compaction of the soil because that affects tree germination and growth. However, when you're building a wetland and you want the clay to have lower permeability, we need to rearrange the clay and compact it. Now this test hole we dug went deep into a silt loam layer that has higher permeability. So Clint placed the clay in the bottom of the hole and he compacted it using the bucket on the excavator. We're going to measure to find out how much compaction he was able to get. Now this is a tool used by farmers to determine whether or not they need to loosen compacted soil in their fields. If they have a compacted layer, it will hold water and their crops will drown. And they need to loosen it. So each one of these marks is 3 inches. On the rod here, we have a narrow tip on it. There are 2 scales on the penetrometer, the one with the narrow tip, the one with the wide tip. And this measures compaction in a very strange unit called pounds per square inch. Pounds per square inch. So the way to look at this is that if you were to weigh 300 pounds and put on high heels and you were to stand on 1 foot, you would be compacting at 300 pounds per square inch. That's what we want. That is great compaction, 300 pounds per square inch. No water is going to leak through that, and more importantly, the crayfish is not able to burrow through it. If we compact this clay, the crayfish can't go through it, the tree roots can't go through it. So it's the bottom of our bowl. So we're going to test it here, and the small tip's on the inside. So if you would, just come here and start pushing slowly, and I'm going to look here, and I'll read off what you're reading. Okay, you're up to 50 pounds per square inch, and the tip is not even going in yet. Put your weight on it. Now you're up to 200 pounds per square inch, and the tip is barely going in, and you're at 250. What happens if you do like a handstand on it? Can you get up to 3? Yes! Yeah. Wow. You just hit, let's see how deep you are. Okay. You went down about 3/4 of an inch and hit 300 pounds per square inch. Well, Emily, it was great meeting you at this workshop, and let us know who you are.
It was so great to meet you. My name is Emily. I am an ecologist with a stream and wetland restoration firm in Lexington, Kentucky, Beaver Creek Hydrology.
Very good. I've heard of them.
So we do a lot of work all across Kentucky, Tennessee, getting into Ohio, and we do stream and wetland mitigation banking primarily, working on restoring degraded headwater valleys in both the streams and then putting the wetlands in the lower big valleys to provide habitat for all sorts of things.
So what brought you to this workshop in Indiana, of all places?
Yes, I was telling my colleagues who were asking if I'd had any experience in wetlands, and I have been working in wetlands since 2016. And in that time, learned your name and the work that you did, looked on your website and found this training course and went to them and said this would be a great opportunity for me to come here, hands-on, learn how to build a wetland. And they said go, so here I am.
Well, that is good news.
Yes.
And you have helped build wetlands as well as streams.
Yes, yes.
And did you find, I have to be careful I ask you, did you find this course to be of any value?
I absolutely did. I learned a lot of new techniques, things to look for, how to address problems as they come up, how to talk with operators, as well as a great networking with the people outside of the state and learn about their missions and goals when working with public agencies. It's been a wonderful time.
Well, I'm just happy you were able to join us and
Thank
that you picked up some information you can use.
Yes.
And I know that over your career, you'll be able to build hundreds, if not thousands of wetlands.
I hope so. I
And let me know if you have any questions about projects. I always like working with participants in the workshops and seeing, their wetlands that they build.
Absolutely. Well, thank you so much.
The first day has been really busy. We figured out where to build the wetland and how to build it using the compacted clay liner technique. Now people are going home for the day, but they were invited to come back in the evening and to listen to a presentation about wetland restoration techniques that I'll be giving. Clint has woken up early the second day of the workshop, and he's out there working on the wetland, finding clay soil and placing it in the basin and compacting it in layers. The participants are showing up. It's a cold morning. One of the first things we're going to do is to look at different drainage structures that have been installed to drain wetlands in the area. Each workshop participant learned how to measure the clay content in different soil samples. We had 10 different samples of soil, and each person was asked to go through these 10 samples and determine whether or not they were sand, silt, or clay, and whether or not there was enough clay in each sample to build a wetland using the compacted clay liner technique. Next thing is a soil sample, and here's a chance to warm up. So who wants to start? This is a 4-foot auger, and it is an open face clay auger. This is the auger that I find works the best for taking soil samples and designing a wetland project, and the soil doesn't get stuck in it. All right, we need somebody to start. Okay, come on up. Your name is? Eli. Eli. Okay, Eli, start in here. Oh, we can look at it in the sunlight. It looks to me like you're still in topsoil. Can you see the grainy appearance of it? The grainy appearance. So then what we're going to do is that we're going to lay that down. We're going to lay that down right next to the hole here. And how it comes out of the auger is a good way to test too. Okay, let's keep going. I think you're still in topsoil. We're going to look for a color change. What horizon is the topsoil? Wow, very good. Are you feeling any rock?
Nope.
Wow, excellent.
There we go.
That's impressive.
Okay.
So Eli went quite a bit deeper this time in a hurry. That indicates he's in clay. Okay, bring it up, straight up. You'll find that clay, it's difficult to pull out of the ground. And you don't have to fill the auger all the way. If you fill it, it's going to be difficult to get out. So in looking at it, I see a shine on it, and it's still dark, isn't it?
Yeah.
See how compacted it is?
Yep.
So we're still in clay. So we can just pull that out of the auger, and we can go back in. To give you an idea if it's still clay, this was on the tip of the auger. We'll pass that around. And it's similar in color to the clay we have over here. And you can tell it's got the big clumps to it. Remember, every wetland fills with water. And when it fills with water, it has to spill out. And you want to make sure that your spillway is wide and gradual so you don't get head cuts and erosion. 9.2 is what we read over there at the 3 flags, and now we're going to subtract from that 9.2 is what we read here. 6.3 is what we read there. So I'm going to subtract from that is 6.3, and that is a 2.9 feet. So right now we are 2.9 feet lower than where the water will spill out of our wetland, 2.9. We want to be 4 feet lower. So 4 minus 2.9 is 1.1. So roughly he needs to dig about 13, 14 inches deeper in the center. 9.6, and he needs to go down to a 10.3, so he needs to go down about 8 inches. Okay, come on out and we'll take another reading. Get right in the middle there if you would. There you go.
Yeah, we were totally in that sandy layer, but that's okay. We're gonna
So now we're in the sandy loam right now. Okay, or not a silt loam, I should say.
Yeah, I can't decide what it is, to be honest. I can't
But it's just
decide if
more permeable.
It's a loam with a lot of sand in it. The sand's finer, so it's harder to pinpoint.
9.9.
9.9, so another 4.
Something like clay on top of sand, sandier layers is the clay will have really tiny pores and the sand will have really large pores. And those tiny pores.
We'll go ahead and mark it. So we're a couple inches too deep, but that's fine. It fills in. So you don't have to protect that flag, but if you want to, you can use it as a guide for coming up. And it doesn't have to come up at a perfect angle. It doesn't. I mean, you're building a wetland here. It's not like a swimming pool, so it can have some dips and all. Everyone watches as Clint, the excavator operator, removes the soil from the center of the wetland basin being built. And what he's doing is he's separating out the silt loam, which is permeable, from the clay. The clay will be returned to the basin and compacted in layers so the new wetland will hold water.
So I don't know if you can see this or not, but there's the light tan on this side, and then there's the darker stuff up in here. So this is the clay. It was a lot darker earlier when he first excavated it. I can't tell, and Clint, maybe you can tell, did you drag this up here, do you think, with the bucket by accident, or do you think this goes down in?
I think that area there goes down in.
So this goes down in. So that means the clay kind of runs like this and kind of over there. So that's all good. This stuff is all the stuff that we're not looking for, which means at this point in time, we're probably going to have to line all of this side. Hopefully there's enough clay up in that area there that we're pulling off. So I'm trying to remember which is the good stuff. That's the good stuff up there. So that's all good clay there. That's good clay there. I think that's good clay there. And then this is all the silty stuff up here. And obviously the topsoil is the big piles in the back. So that's kind of where we stand now. Ironically, if we built the wetland probably 200 feet that way, we may not have even had to deal with this, potentially, right? But we are where we are. If we need more clay, we may end up making it a little bit deeper on this end and using that to pile it onto this end. That's certainly an option.
The way it's built, it's going to hold water, but the more clay we put in, of course, the longer it will hold water.
So what I want you guys to notice is that the layer of deposition of the clay in this area with the sandier textures, it varies, right? Do you remember when we looked at the side profile of the soil profile that there were wavy boundaries for the horizons that we looked at? If you look right here, there's a bit of that clay layer, that darkness that comes closer to the surface, versus right here, it's the sandier layer. Do you see the color difference there between the dark and that one little patch? So when we're looking after taking all of those horizons off, and yeah, some of this has been mixed around by the bucket, but when you're looking across this surface, you can see the top of the undulation of those horizons and why it's so important to understand the different layers and how the texture of them can change water movement. Because if we had nothing but this clay, we would be able to continue on without having to worry about it holding water. But since we have a significant amount of this sandier material, now we need to make sure that we're going to put in a clay liner over the sandy material to make sure this can hold water, because this sandier material transmits water really well. And that's not the goal of building a wetland, right? If you were building a house or something on this sandier material, or if you were putting in a septic system, this would be ideal.
I don't think that's a clay pile. It may have a little bit of clay in it, but it doesn't look like it right there. So the next step is that he will start moving this in and then track packing it instead of using the bucket. If he uses the bucket, he'll be another week. The excavator operator is now spreading a layer of clay in the wetland basin that we're building. And this clay is spread in a layer about 6 inches thick. And we're making sure that there aren't any rocks or any big clumps in that layer. And as he spreads it out, he's also starting to compact the clay. And we want to make sure that this clay is really compacted. The excavator operator begins traveling over that layer of clay that was spread, and he goes in 2 different directions at right angles to each other and wants to make sure that every area of clay is run over at least 3 to 4 times. And we're measuring how compacted each layer is using the penetrometer. And compaction takes quite a bit of time. This technique is not a fast one to use in building a wetland, but you have to ensure that every piece of that clay is compacted so the wetland will hold water. We're here with Clint Skirvin, and he has been operating the heavy equipment to help us build wetlands at Ball State University, and this is our 4th wetland workshop together. And we schedule these in advance. He's a very busy guy, and he makes time to come out here and to run the heavy equipment, to provide the heavy equipment to get us to build the wetlands. And Clint, we really appreciate what you do, but I'm wondering, why do you do this? This can't be a moneymaker.
I enjoy it. It's actually a learning experience for me also, and you know, it's kind of nice to see the class out here getting involved in it, and people understanding, you know, the way that the land works, and it's pretty interesting.
Do you think that people are learning that heavy equipment can do good things to help the environment?
Oh yeah, oh definitely.
Yeah, you've been really good explaining everything to the students and showing them that they can get along with you, and also, you know, describe what needs to be done.
Yeah.
Anything that you see the students picking up on?
I mean, they just asking a lot of questions. That's, you know, I do notice that, but I mean, that's about all I can think of on that part.
Now, we're going to have to show you what some of these wetlands look like. They look really good. We always put you on the sites and say, dig, 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 dig.
Yes.
The one we're working on here is a bit of a challenge. We found a lot of area of silt loam, and now you're going to put clay on it. So let us know, what's your next step in building this one?
Well, now I'm going to finish taking this clay off. I'm going to put it in a lift about a foot, and I'm going to start packing it in so we can seal it up. So hopefully we don't have any leakage.
So you're going to block that silt loam, which is permeable, and with some clay layer.
Yes.
And then we'll put some topsoil in and add some woody debris and have a great looking wetland. So it's been a really good project. It's too bad we can't see underground. We would have moved it over and
Yes.
got you into better clay. But next time we have a workshop, we'll have really good clay.
Yes, definitely.
But really appreciate what you're doing. Thank you.
Well, thank you for having me. I really enjoy it.
Okay, folks, come on out. We'll do this. We didn't want to stop you, Clint. This is a quick way to test compaction. Another way, you could use your heel. You can even use a tile probe. Whoa, what were you hitting there? You were in the do not exceed. You know what happens? It explodes.
This is donut exceed.
You were over 300 pounds, weren't you?
I am, yeah. I'm 580 pounds.
Let's try another one.
Right in between the tracks. Everybody goes for the flat spot. Go for the ridge in the between. See if that happens.
Uh-oh.
See if that changes.
Okay, I'm going to read it. Oh, my word. He went way over 300.
Still in that spot.
Took it into the red.
They think there's a soft spot up here. Hand it to them. There's a soft spot up there.
Took it into the red. What are you reading on the scale for small tip? Is it going down or is it stable?
Even in the soft spot.
Even 300. Wow, folks.
The big seeds are like the milkweeds, and it goes all the way down to things like that ditch stone crop and some of the fine seeds like the penstemon, the really tiny seeds. So I wanted to have the full range. You could grab it and they won't settle. So if you like used a hand crank seed spreader, that would be great if you have one size seed. That way you don't have the little ones working their way to the bottom and getting thrown out too soon. And I want to be able to see what I missed and go over it. So what I did, I've got 3 trash cans. I have 2 with seeds mixed in with the shavings, and I have about 1/3 or so of the seeds that I bought left over, so that when this is all done and those piles are moved and we have some bare space that's exposed, then we can come back and throw those seeds down. The idea is I take these 2 cans and I try to cover the whole thing, cover half of the area with 1 can, and then cover the other half with the other can. And that never happens. So you've got 1/3 of it left over to hit those spots that you didn't get to. Sometimes that's 1/3 of what you're trying to do, and that just works out right. Otherwise, you can just double up some areas too. So that's why we have these. And so I want everybody to come and take a look and see. You can see the shavings, but you can see the little dark seeds in there. You can't see all of them, but you can see some of them. And then I'll go and get the seed mix that I bought, and you can see what the components are in those bags.
We're now in the final steps of compacting clay in the wetland basin. We've been doing the measuring, and we found that we have close to 24 inches of compacted clay in the basin, and this has taken quite a bit of time. I find that it takes the most time to build a wetland using a compacted clay liner technique than any other method. After the clay is compacted in the new wetland, it's time to spread the topsoil. We saved the topsoil early on in the construction process. Now we're using the excavator to loosely spread it throughout the wetland area and the area surrounding the wetland that we just built. One of the final steps is returning the wood that we removed to the wetland that we've just built. This wood is placed in a natural looking pattern, and it gives salamanders a place to attach their eggs in the spring, and also gives birds a place to perch, as well as dragonflies. And the wood is such an important part of restoring a wetland area, and every single wetland that we build, we try to return wood to it when we're finished.
Misty, what brought you to this workshop?
Well, I am a Ball State student, and I've been working with natural resources seasonally the past 3 years, and wetlands were something that I had a great interest in, but not a whole lot of information to back it up. I've had a couple coworkers and fellow students who were like, you should do this wetland workshop. It's only around every couple of years, and I am very glad I made the decision to check it out. It has been awesome. The whole team here, including the educators and the sports, have been awesome. I feel like I've learned a lot. I've take a lot of good notes, so I'm very excited to keep those with me and to reference them after I leave today. I think one of my favorite things has been watching the landscape change so much behind us in just a couple days. It's crazy what all you can accomplish with a big group of people and a lot of enthusiasm, and I hope that there are more wetland workshops to come here at Ball State. I think it's an awesome opportunity, and I know as a participant I had a blast.
Excellent. Well, was there anything in particular that you really took away from this class?
Well, I liked, one thing I would say is the level of notes and resources that were provided for us. I think as someone who likes to reference back quite a bit and hopes to use this information in the future, just the level of organization and the level of details put into that alone, I think is going to be something that's wonderful. When it comes to the actual class itself, just seeing everybody come together so enthusiastic about a cause like this. I've learned a lot about other critters that are going to be benefiting from this habitat that I hadn't originally thought of before. Just in general, I feel like the atmosphere is something super positive, super awesome, a great place to learn. I think if I had to choose a favorite thing, I think it would be learning about the different kinds of wetlands. When you think of a wetland, at least when I thought of one before this, I usually thought of swamps and things of that nature. Learning how diverse they can be and what diversity they can welcome, I think has been my favorite thing.
Well, thank you.
Of course, thank you.
By the end of the day, we will have completed a very functional and natural looking wetland. You're going to see that we will get rid of the saucer shape and that we will have it landscaped so it looks like it's been there. By next year, it'll look quite natural. The piles we're leaving, they can be expected to settle at least 50%, maybe 75%, which is good. Now, as you work to design wetland projects and build wetlands, stay in contact with me. I really enjoy catching emails from you and show me the sites you're working on. I do this with many people, and it's volunteer work. I'm not going to be charging you. You just say, can I ask Tom? Yeah, send an email to me. I'm not very good at returning phone calls, but emails, I'm really good at that. And let me know if I can be of help to you. And safe travels home. We do have certificates for everybody. So really, thank you for being here. Appreciate it.
Thank you.
Oh, thank you. Good. Yes, I agree. This is Tom Biebighauser. Are you interested in attending a wetland restoration workshop? To find out about these, go to my website and sign up for my newsletter. Are you interested in hosting a wetland restoration workshop? This requires quite a dedicated effort, but it is worth it. This is the best way to show people how they can plan, design, and build a wetland in their community. all you have to do is contact me. We'll talk about it and we'll make arrangements where I would visit your community and help you design these wetlands and then plan for the workshop. But more importantly, I'd like you to like this video and to subscribe and to let other people know about it and to visit the website for wetland restoration and training. Thank you.